Grading Intermediate Algebra. Chapter 9 has just 2 sections that we'll cover. It's usually treated as relatively optional, but there are things that I do want to talk about, so let's go ahead and get through it. So this is a combined section 9.1 and 9.2, which is about what is a function and then evaluating functions. So every set of ordered pairs is a relation, but a function is a special relation for each input. There's exactly one output. That means every x value has a specific y value assigned to it, and it can't go to multiple different y values. So when you're asked if something is a function, for example, the set of points 4, 5, 5, 7, 6, 1, and 2, 4, you're looking for if the x repeats, and if it does repeat, if it's going to different y values. So here we don't even see the x's repeat, so this collection of points, C, is a function. Now we can see this in different forms. Is this table a function? Again, we're looking for x values repeating. So here we see a 2 and a 2. Now it's not good enough just to see that it's repeating, you have to see what it's going to. 2, -1, and 2, -7. Those two things are different, therefore that there's an input that has more than one output. That input is 2, which means this thing is not a function. Now the last kind of way you could see this problem is in kind of a bubble matrix style. These are the x values and these are the y values they go to. The big red flag, if you're seeing this kind of thing, is an arrow coming out of the same x value to 2 different y values. It's okay if 2 different x values go to the same y value, that's fine. So this thing doesn't have 2 arrows coming out of the same x, so this yes is a function. Now, in addition to functions, they have domains and ranges. For discrete functions, that's not bad. But the domain is the collection of all the x values you see. The range is the collection of all y values. So determine if the following relations are functions and find the domain and range. So again, I see my x values 5, 7, 9, -2, and 7. I see these 2 different ones where 7 is starting. They're going to different y values, so it's not a function, because we have 7, 4, and 7, 3. However, we can still do the domain and range, even if it's not a function. The domain is the collection of all x values that you see. So what x values do you see here? 5, 7, 9, -2, and 7 again. You don't need the repeats. You just need each individual one that you see, and you only need it one time. I'm going to put them in order. So -2, 5, 7, 9. Now these are a set of points and not like a range, so they're discrete values. What that means is it's just a collection of points. It doesn't imply that there's a line that goes from here to here. Anything could be happening. When you have discrete points, you put them in braces and you separate them with commas. And we do the same thing for the range with the y values that we see, which is 3, 4, 6, 1, 3. That's a 1, a 3, a 4, and a 6. I will not take off points if they're in a different order. You just do your best and practice drawing your braces. If we look at B, again, we have 2 and 2. It repeats. However, they both go to the same -1. So if you have one that repeats, but it goes to the same place, it doesn't remove its possibility of being a function, so this is still a function. We can still do the domain and range. We see 2, 4, and 6 for the domain. The range is just -1, since everything maps to -1. Lastly, here's a set of bubble domain and range for input-output. Now 2 has 2 arrows coming out of it, as does 3, so this is not a function. But again, even when it's not a function, we can still do the domain and range of the relation. Domain is 2 and 3. The range is -7, -1, 3, and 4. Okay, so that's if you have a set of points in various forms, but what if you have a graph? How to determine if it's a function? So let's look at this. So in the past you've probably heard of this before, but it may have been a while. You've got what we call the vertical line test. Because the vertical line test, if it hits the graph in 2 places, that means you have an x value with two different outputs, or y values, which is exactly what you're trying to avoid if it's a function. So y equals x as a graph is the diagonal line through the origin. Here, it's y equals x. That's a linear. If we try do the vertical line test, it's drawing a vertical line at any point through the function. You should only touch one time. It's clear we're not going to hit the function more than once, which means this passes the vertical line test, and it is a function. X equals negative y squared. I'll tell you what this shape is. It is a sideways parabola to the left. So it looks something like this. Now it's clear, if you draw a vertical line through it on the left side, you would hit 2 points quite often, so it fails the vertical line test, which means it's not a function. And lastly, we have y equals x squared, which is that same parabola, just as facing upward. If you draw a vertical line anywhere through this, it will not touch more than once. Even though it looks like it starts getting vertical here, it doesn't. So this passes the vertical line test, which means it is a function. So that's how you do it on graphs. Lastly, let's talk about evaluating functions at values. So evaluating functions. For any function f, the meaning f of 1 is the value of the dependent variable when the independent variable is 1. I like to think of it in this way. What's the difference between these two things? F of x versus f of 1. Here we have an x. Here the x has been replaced by 1. If you replace the x on that side with 1, you'd have to replace the x everywhere in the equation with 1. So when evaluating at a value, your answer will be a value. When evaluating at a function or expression, your answer will be an expression. We won't do evaluating an expression here, but we will when we get into college algebra in probably 2 to 3 weeks. We will be at that point. So let f of x equal negative 2x squared plus 3x plus 1. Find f of 2. So again, replacing x with 2 on the left, which means we replace all of the x's with 2's. Well, knowing our order of operations, 2 squared is 4, 2 times 2 is 6. So we've got negative 8 plus 6 plus 1, which is negative 1. So f of 2 is negative 1. Now, I know we're not the biggest fan of the fractions, but we can still do it. And again, on A, every time we're doing these, evaluating functions, the most important thing you can do is to remember order of operations. So f of 1/2 is negative 7 times 1/2 plus 5. That's negative 7 over 1 times 1 over 2. Remember, you multiply across for fractions. Negative 7 over 2 plus 5. To add these together, I need a common denominator, which means I need to multiply by 2 over 2. So negative 7 over 2 plus 10 over 2, which is 3 halves. So f of 1/2 is 3 halves. And that's really all for chapter 9 and the two sections that we do in there, 9.1 and 9.2.